At 06:17 a.m., March 7, 1945, on the coral dust apron of Boeing B-29 Superfortress base on Islay Field, Guam, the deep thrum of 4 twin-row radials pulled the bomber toward the rising sun. Flight Engineer Samuel "Sam" Donnelly crouched at the port outer nacelle, wrench in one hand, oil-soaked rag in the other, watching the glowing manifold ahead. He'd just tightened a hose clamp on the Wright R-3350 duplex Cyclone No. 4 engine, again, after a minor leak reported last sortie. A blast of supercharged air rattled the nacelle, the turbo supercharger whine spiking. Then, silence. The prop slowed. Sam's heart skipped. On the radio, the pilot barked, "Abort takeoff, engine fire warning, right wing." Oil flames licked the wing root. A crewman yelled something about magnesium crankcase burning. With the full weight of the bomber and 100,000 lbs of fuel, nothing short of a miracle could stop this one. Sam froze. Not far off, 5,000 engines were counting on his next fix, if this one survived. At 04:30 a.m., the airstrip at Islay Field, Guam smelled of diesel, jet blast exhaust, and salt-laden humidity. Sam Donnelly climbed down the ladder from the forward equipment bay of the B-29 assigned to the 403rd Bombardment Group. The bomber's 4 massive cowled engines glinted in the half-light, each housing an R-3350 radial, 18-cylinder behemoths, rated initially at around 2,200 horsepower. Sam's boots crunched on the tarmac as he made his way to the maintenance pits. Around him, mechanics in oil-stained coveralls swapped gearboxes, checked magnetos, and refilled oil reservoirs. The ground crew joked that each engine had a flamethrower built in. "We just hope it stays inside," one quipped. Sam nodded but didn't laugh. He knew the truth. The R-3350 was prone to overheating, oil leaks, reduction gear failures, and magnesium alloy parts that fed fires. He paused at engine 4, the one flagged yesterday for, quote, "excess oil seepage, lower left banjo-fitting, tighten and recheck." A metal tag fluttered. "Caution, crankcase oil leak, monitor on next run-up." He inhaled warm air from the cowling vent, felt slightly hotter than normal. His fingers brushed the surface, faint vibration. The pilot wanted takeoff in 2 hours. Sam's goal, make sure this engine didn't ignite before liftoff. At 05:15, the mechanics fired all 4 engines for taxi checks. Sam listened to the frequencies, 120.8 for tower, 251.2 for the group lead. He tapped his headset mic. "Flight Engineer Donnelly to control. Engines green, oils check at 120 psi, temps rising." The tower responded, "Taxi hold, wind from low 40 at 12 knots. He glanced at oil temp gauges on the station, engine 4 creeping toward 155 degrees Celsius head temperature. At this altitude and humidity, that was worrying. The takeoff weight today, full bomb load, full fuel, full range to Japan. Every piston turning meant enormous heat dissipation. Sam's hand hovered near a clamp. He felt the vibration shift as though the engine exhaled something unexpected. He tightened the clamp once more and said quietly, "Not today." At 07:02 a.m., the bomber was lined up at runway 07L, flaps set, props at full fine pitch, the engines spinning with a low thunder. Sam sat in the flight engineer's station, scanning 4 oil pressure gauges. Number 1, 85 psi, number 2, 82 psi, number 3, 88 psi, number 4, 73 psi, lower than usual. He keyed the intercom. "Prop temperature rising on 4, might need to lean mixture on next leg." The pilot, Lieutenant Colos Harris, nodded without responding. The bomber roared. At 07:05, the stick shaker vibrated as the aircraft lifted. Sam felt the vibration through his seat. On the climb out to 20,000 feet, the target, a Yuwata refinery raid in Japan. Real operational range, nearly 1,500 miles from island base, high altitude, full bomb load. Back in the maintenance pits an hour earlier, Sam had overheard a memo from Depot 3. Engine fire rate unacceptable. Crews report oil collecting in nacelle bottoms, ignitions via manifold cracks. He'd filed a supplementary checklist. Inspect banjo fittings, ensure manifold bolts torqued to 120 inch-pounds, confirm firewall integrity. But logistics in the Pacific meant spares were spare and replacements slow. Now, as the B-29 leveled at 25,000 feet, Sam watched Engine 4's cylinder head temperature spike, 550 degrees Celsius, creeping near red band. He flicked cowl flap controls, open a fraction. The wing nacelle heat shimmered in the bright sunlight. From the bombardier's compartment, he heard a soft click-click, bomb bay doors arming. The bomber's mission: carry incendiary bombs to burn Japan's war plant hubs. The weight, the altitude, the humidity, all pressuring the engines. He whispered into his mic, "Number 4 trending hot. I'm going to lean mixture 50 RPM. The prop sync control beeped green. Suddenly the vibrations spiked. Sam leaned forward. The panel above his head rattled. Cowl flaps chewed the hum of airflow. The mission pressed ahead. A faint wisp of smoke drifted from the number 4 nacelle gap. He reached for the fire handle, but the pilot didn't yet give that call. Sam thought, if I pull early, we abort. If I don't, we might burn. At 07:42 a.m., 300 miles out over the Pacific, the bomber held formation at 27,000 feet. The sun beat through the plexiglass dome, heating metal surfaces. Sam's sleeve stuck to the console. He sweated. Below him, the flight engineer's ladder led down to the wheel well, cold at altitude, but inside the cabin a furnace. The remote gun turrets clicked as gunners scanned for zeros. The bombardier's sanctum glowed blue-green from radar. Into his headset came the lead's message, "Approaching rendezvous. Stand by number 2 and number 3 heaters for brief." Sam exhaled. He switched each heater to minimum. The added electrical load would stress already hot engines. He looked again at number 4 oil pressure, creeping downward to 68 psi. Notes from Depot 3 warned oil leaks combined with vibration could lead to fire. Sam patted the manifold tops. Through the panel, he felt the heat gradient shift as airflow decreased across the engine. The cause: dense humid air at altitude, heavy aircraft, and that damned manifold still hotter than it should be. He leaned into the mic. All fuel flow gauges show 1,050 gallons per hour on number 4. Nominal but trending high. I'm opening cowl flaps to 45%. The pilot said, "Do what you must, Sam." Sam felt responsibility. Crew lives, bomber weight, mission. He toggled the lever. The airflow sucked. Wind shrieked in the vent. Outside the port wing, the nacelle quivered under stress. He thought of the note from commander of the 58th Bomb Wing. "Preventable engine fires cost us more than enemy flak over Japan." Sam gripped his wrench under his seat. The mission pressed ahead. The fire indicator light beside engine 4 flicked faintly with a soft tinkle. Sam's heart jumped. The faintest red glow appeared on the nacelle's upper edge. He swallowed. At 08:30 a.m., nearing the Chinese coast staging point, the formation slowed, and Sam used the intercom. "Engineer to pilot, number 4 showing 570 degrees Celsius, CHT, oil at 62 psi, cowl flaps at 45%. I'm reducing boost to 38 inches mercury on that engine." The pilot nodded. Suddenly the bomber jolted. The number 4 propeller RPM dropped from 2,600 to 2,400. The flight engineer yelled, "Prop sync out!" Sync light flickered. Sam punched the prop feather switch, but nothing happened. The vibration worsened. He felt the whole wing flex under his boots. He slid from the seat, made his way into the nacelle walkway. The catwalk tunnel vibrated. His headgear pressed into his skull. With flashlight in hand, he opened the panel to inspect the accessory case. Oil sheened across the floor. A flicker of orange glowed ahead. A small flame in the oil pan vent. He jumped back, fingers locking the panel. He radioed, "Fire in number 4 nacelle. I'm going to discharge." The pilot responded, "Confirm, number 4 fire, shut down." Sam grabbed the fire bottle lever, pulled. The hiss of halon filled the inter-nacelle tunnel. Smoke thickened. The bomber rocked. The bombardier's voice came on. "Flames sighted under port wing route." Sam's throat tightened. The smell of burning oil filled the cabin. He backed out, slammed the hatch. He could see the wingtip flex. Rivets popped. He reached his ladder to return to the flight deck. On the intercom, he told the pilot, "We lost number 4. Let's land at Iwo Jima, first available." The pilot acknowledged. "Lead is initiating breakaway." The bomber yawed sharply. The other 3 engines roared to compensate. Sam watched the flame grow, licking the underside of the wing, the magnesium crankcase glowing white-hot. At 08:45 a.m., the formation broke. The B-29 fell out of position, trailing wisps of black smoke. Sam worked the checklist: engine 4 shut down, fuel feed cut off, prop lever to feather. The prop slowed from 2,600 to 1,200 RPM, then turned grey and vibrated. Oil pressure dropped to 0. Sam tapped the console. "Number 4 secured. I'll monitor wing temperatures and ready fire handle if wing spar smoke appears." The pilot set a heading to divert to Iwo Jima. Outside the window, the wing's leading-edge skin panel above nacelle 4 blistered, the heat shimmering in the tropical air. Sam calculated. At climb power, the wing spar could melt in seconds if heat penetrates the firewall. The memo from Depot 3 had warned, "Fire through firewall will result in wing spar failure in less than 30 seconds if magnesium crankcase melts." He felt the weight of everyone's lives on his action. He moved again into the nacelle tunnel to inspect the fuel line manifold. The banjo-fitting he had tightened yesterday was sheared. Oil had seeped before, but now it had ruptured. He sighed. He'd adjusted it, but the odd vibration at altitude overtaxed the joint. Sam flicked the camera lamp. He recorded the crack, typed up a note. Banjo-fitting failed. Oil leak resulted in fire. Later this would go into the engine log of the 433rd. The bomber shuddered as the pilot began descent. Sam climbed back to his station. He heard the crew chief's voice. "Wing route starting to glow. Donnelly, get ready for emergency evacuation." At 09:10 a.m., the B-29 approached Iwo Jima's airstrip. Sam stabilized the 3 remaining engines at 80% power, set flaps. The fire warning light beside number 4 still glowed. Subtle heat radiating. His breaths came heavy. The sound of airflow cut around the open wheel well doors on descent. Sam glanced at the wing spar skin above the nacelle. The orange heat halo had grown, rivet heads turning silver. The tower came alive. B-29, 4-engine inbound. Declare emergency. Runway 23 right, wind 060 at 15 knots. The pilot acknowledged. Sam climbed into the nose wheel well to watch the left wing flex under weight. He leaned his flashlight onto the firewall. The protective sheet metal buckled, paint blistering. He muttered, "That firewall's just a tin pan." A ground crew veteran had used that phrase earlier. Sam's heart pounded. The bomber's descent path steepened. The pilot throttled back. Sam checked his checklist, then activated the fire foam nozzle from the engineer's station just before touchdown. Foam sprayed. Outside, ground crew in yellow vests hustled. As the wheels hit, the wings sagged faintly, then the pilot eased the yoke back. The B-29 rolled out. Sam exhaled. But as they exited runway, the wing spar let out a sharp ping, metal fracturing. The bomber rolled into the parking area, Engines shut down. Sam pounded the console. Complete. For the moment, they survived. Sam climbed down, landing gear lowering, headphones off, fingertips stained with oil and smoke. He thought, "We didn't lose the airplane today, but we came within seconds." At 10:30 a.m., in the maintenance bay at Iwo Jima, Sam joined the crew chief and engineers under the left wing. They stood in the heat of the tropical hangar. Bare roof, no walls, reviewing rope lights illuminating the spar and nacelle. The captain's log entry read, "Engine number 4 fire due to oil line rupture. Wing spar heat damage suspected. Investigation continuing." Sam added his note. "Clamp failure preceded oil flow. Do repeated torque verify clamp in future." The flight engineer and Sam discussed the root cause. A small banjo fitting, under high vibration and heat, sheared. The oil spray hit the hot manifold, ignited, fire backed into nacelle, magnesium crankcase intensified, firewall inadequate, heat reached wing spar. They calculated 30-second window before structural failure. The records were stark. Loss rate due to engine fires on B-29s in Pacific, 267 of forward 14 lost to mechanical causes. Sam's goal shifted, not only keep the bomber flying, but prevent the mechanical attrition that was costing bombers faster than fighters. The lead engineer turned to Sam, said, "Your clamp test and torque check method is good, but we need something better, redesign or substitute new fitting. When you're ready, you'll run trials on the test rig." Sam swallowed. This was more than maintenance. This was engineering fix. He accepted. He turned to stand under the wing's shadow, hearing the roar of taxiing bombers, thinking, thousands of engines, one failed clamp, our margin is paper thin. At 11:45 a.m., in a makeshift test rig under the shade of a tarpaulin on the apron, Sam and a small team ran repeated vibration tests on the oil line banjo fitting assembly. They jacked a spare R-3350-23, mounted a vibration sensor near the fitting, and ran 80% power for 1 hour. The oil line clamp loosened. The sensor data showed micro movement at 0.015 inches, amplitude at 240 Hz, beyond spec. Sam marked the data. Original fitting vibration, exceed limit of 0.0010 inches at 200 Hz. The engineer handed him a new design. Larger diameter, Loctite compound, reinforced bracket. Sam nodded. They fitted it, reran the test. Amplitude fell to 0.06 inches. The team cheered. Sam's heart swelled with quiet satisfaction. But then the fire tech asked, "What about manifold heat soak? That remains unchanged." Sam scanned the data. He flicked a page. Manifold surface reached 750 degrees Celsius in prolonged climb simulation. Oil sheet ignition threshold for alloy oil at 320 degrees Celsius. The gap between a component and disaster. Half a second. He noted. Consider thermal shield on manifold. The challenge spiked. Flight operations demanded bomber sorties every 48 hours. Engineering delays meant fewer missions. The pilot's voice. "We can't wait weeks for fix." Sam felt the pressure of combat tempo. He reached for his notepad. "Pilot will be briefed to avoid climb out greater than 3,000 feet per minute until fix fitted." From across the base came the roar of 4 engine bombers lifting. He leaned on the frame and thought, "We'll either fix this, or we'll burn wings off bombers while they climb to Japan." At 02:12 p.m., March 12, 1945, at the test modification hangar on Guam, Sam gripped a socket wrench, sweat glinting on his brow. One B-29 sat on jacks, engines removed, the port outer nacelle open. The new banjo fitting had been installed, plus a thermal shield plate around the manifold and an improved fire detection sensor. Sam's goal: run ground test and simulate full power takeoff climb. Crew chief shouted, "All clear, fire bottles armed." Sam climbed into the engineer's station. His finger hovered near the engine fire toggle switch. He keyed intercom. All systems green. Start engines number 1 through 3. Spool number 4 on bat start. Engines roared. He leaned in, watched gauges. Oil pressure good, temp stable. At 30% RPM, everything normal. Then throttle forward to takeoff power. Prop pitch fine, boost set at 40 inches mercury. The vibration sensor beeped as expected. Sam noted cowl flap opening, 0% to 15%. 5 minutes into simulated climb, manifold temp jumped to 820 degrees Celsius, higher than before. But the thermal shield held. The firewall surface remained at 105 degrees Celsius, under warning threshold of 120 degrees Celsius. The sensor near banjo-fitting held steady. Oil contamination remained 0. Sam's heart pounded. He keyed. Cut to normal climb power. The engines responded smoothly. The test concluded. The team unfurled a banner. Fix approved. Sam exhaled. His eyes closed briefly. Around him mechanics cheered, slapped backs. Yet in Sam's chest, a still quiet worry. Would the real mission profile, full bomb load, long climb, humid Pacific air, still push this to failure? As the sun lowered and shadows lengthened, Sam documented the test report. New banjo fitting with Loctite compound and shield plate effective. Recommend fleet-wide retrofit. He sent it up the chain via teletype. Sam walked out of the hangar, ears ringing from engine growl, and thinking, if this holds, we save 5,000 engines. If not, we may lose 5,000 bombers. At 04:05 a.m., March 15th, 1945, on takeoff from Guam for a daylight raid on Osaka, Sam sat at his station in an upgraded B-29. The tag on engine number 4 nacelle read, retrofit banjo fitting and shield plate installed. He patted the panel. The aircraft taxied into position. Pilot leveled throttle. Sam monitored engine 4, oil pressure 90 psi, temp 260 degrees Celsius head, 1 to 50 gallons per hour fuel flow. He smiled. Solid numbers. The bomber lifted. The climb out to 25,000 feet proceeded smoother than prior sorties. Sam watched manifold temps stay around 700 degrees Celsius instead of 820. Sweat still beaded on his forehead, but not fear sweat. Still, as the bomber leveled off and joined formation, Sam felt a tremor. Engine 2 began to vibrate mildly. He keyed the mic. Number 2 vibration, 0.011 inches amplitude. I'm going to trim mixture. The pilot responded. Proceed. Sam made minute adjustments. The vibration lowered. He logged. Minor trimming. As the lead bomber peeled away toward target, they entered thin cloud deck at 24,000 feet. Sam felt the aircraft shudder as bomb bay doors began to open. He tapped the checklist. Suddenly the intercom hissed. Turbo supercharger over temp on number 3. I'll manage. Sam calculated present power margins. 1 engine trending high, 1 stable, 1 moderate. The bomber's 4 engines, mission load, tropical humidity, complex equation. He closed cowl flaps slightly and reduced boost on number 3. The navigator reported, estimated time to target, 45 minutes. Sam exhaled. He thought back to the lab test victory. He knew this real-world pressure differed. For nearly 30 minutes the engines held. Then, Engine 4's fire sensor test triggered. Not for fire, but heat soak alert. 118 degrees Celsius firewall. Sam pressed the visual indicator confirm, glowing nacelle skin. He toggled auxiliary fan in nacelle. He radioed. Mod plate doing job, but firewall still at limit, monitoring. They survived the segment. Sam's chest tightened. This one flight might become the proving moment. The bombs dropped, the flares of incendiaries lighting Japanese industrial zones, and Sam realized the repair was in the crucible now. At 06:53 a.m., on the return leg over the Pacific, the bomber's 3 engines hummed. Sam reclined briefly, glancing at records. The new fitting and shield plate had held during climb, cruise, and bomb run. He allowed a small smile, then a jolt. Engine 3 dropped to 200 RPM, warning light flashed. Sam lunged into action. He flicked the rock switch. Prop feather lever. Nothing. The prop still at 1200. Vibration spiked. The wing drooped. Sam shouted, "Engine number 3 failure. Feather lever stuck." The pilot banked gently to drop altitude and conserve fuel. Sam raced into the nacelle tunnel of engine 3. Oil had sprayed from the accessory case. Another banjo fitting had sheared. Sam's stomach dropped. The new fix had not covered engine 3. He tapped his wristwatch. Mission elapsed 2 hours 48 minutes. They were over open ocean, still 900 miles from base. He grabbed a spare clamp from his kit and attempted field repair in the tunnel. Heat, vibration, wind buffeting the fuselage. He worked quickly. New clamp installed, torque checked to spec. He closed the tunnel hatch and radioed. "Support station. Repair done. Try feather." The pilot reset prop lever. RPM dropped to 500. Vibration dropped. Sam exhaled, but the engine was unusable. The bomber climbed again using only 3 engines. The weight still full, fuel less. His heart hammered. He returned to his station. In minutes he logged, "Clamp failed at 0.04 inches amplitude vibration. Design revision required." The pilot declared, "We'll make it home." Sam whispered, "We'd better." The coast of Guam came into view, the bomber limping on 3 engines. Sam's mind racing through the implication. 1 engine gone, but bomber saved. The retrofit worked in general, but not universally. The battle wasn't over. At 08:24 a.m., March 15, 1945, the damaged B-29 taxied to its dispersal pad in the steaming dawn. Sam climbed down the ladder, boots wet with dew, face smeared with oil and soot. The crew gathered around. The pilot shook Sam's hand. "Couldn't have made it without you." Sam nodded, but his gaze drifted to the wing route where the repair team would replace engine 3, inspect wing spar heat damage, repair firewall buckling. The log would read, "Mission accomplished. 4 engines built by Wright, flown on B-29. Several had losses to fire. Repair rate unsustainable. The clamp fitting redesign may reduce attrition." Sam walked to a shaded bench, removed his oil rag from his pocket and laid it on the concrete. He felt the magnitude. His fix might save up to 5,000 engines in the Pacific. The broader statistic, the B-29 lost 267 of 414 bombers to mechanical and engine incidents, not enemy fire. He inhaled deep. The base horns sounded. Next takeoff in 2 hours. The depot crew had to retrofit dozens of B-29s with the new design. Sam's mind raced. Supply lines, training, torque spec sheets, field kits to remote bases. He stood up. Sam gathered his kit and walked toward the hangar, thinking, "We began here 1 clamp at a time. Now the war demands thousands of them." At 12 p.m., in the shade of the technical orders trailer outside the maintenance area, Sam typed the final report. Implementation of banjo-fitting redesign and thermal shield plate on manifold has resulted in 0 fire events in 52 engine hours across 8 retrofit B-29s. Recommend fleet-wide mandatory use. Continued monitoring of manifold temps and firewall radiant heat required. He signed, S. Donnelly, Flight Engineer Mechanic, 433rd Bombardment Group. Nearby, a bulletin board displayed a photo. A B-29 returning from mission with wing route charring but fire blocked. The caption, "Successful engine fire containment." Sam touched the black and white face of the aircraft. 4 engines still turning. Bomber still flying. He thought of the crews, the ground staff, the young pilots who climbed out of twin-engine trainers into 135,000-pound bombers. The pressure, the sweat, the dust of coral runways. The average engine life before overhaul in the Pacific was only 265 hours for R-3350s. He looked toward the row of parked B-29s, ready for the next mission. He remembered the prologue, the morning of the aborted takeoff when Engine 4 nearly burnt the wing spar. That near disaster sparked the invention. Now thousands of engines would be saved. The weight of each engine, tons of metal, power, life, felt in his hands. He smoothed the report, locked it in the dispatch box. He silenced his thoughts. The war still raged, but for a moment he allowed himself pride, not at explosion, but at prevention. In the fading light, Sam walked off the apron. The air was quiet now. Somewhere behind him, one of the B-29s fired its 4 engines and taxied into the sunset. He paused, listening to the thunder down the runway. The machines roared, but fewer burned. He smiled faintly. A clutch of bolts, a reinforced bracket, a thermal shield plate. It was enough. A human fix, a bomber spared, a step toward victory. As chief of the Pacific Maintenance Command put it, engine fires were the single greatest attrition cause for the Superfortress. Every mechanical failure had to become an engineering fix before we reached Japan. Archive, United States Army Air Forces Maintenance Report, 58th Bomb Wing, April 1945.